This is the first conference that makes me feel like Justin Bieber. Do you see the stage? Just awesome. Somebody asked me to mention something before I started the talk. It's very hard to see you all, but it's not important. That's better. Who had barbecue last night? Who noticed the two guys that spent 3 hours baking meat for us? Candid and Adrian. I organize a conference myself, and we often forget the volunteers, so I think it's important to, whenever you see somebody in a blue t-shirt, I think they are blue or black? Well, we ran out of blue t-shirts. Some of them were black, but they had to do that. Anybody wearing a t-shirt, just give them a hug. Good. I'm Wim, and I do absolutely nothing. I actually have proof. This is a t-shirt I got from Duo Security for doing absolutely nothing. I think everybody should do more of absolutely nothing. No. I'm a managing consultant at IOActive. I'm the chairman of the board of IC². Don't hit me for that, no tomatoes. I'm an organizer at Brucon, and I co-developed the penetration testing execution standard. If you're not familiar with it, look that up at penteststandard.org. And it's basically around that time when we started developing that I basically fell in love with threat modeling and was looking into how can I apply that more, work with my clients to do more threat modeling, build security into systems from the beginning. Everybody knows that threat modeling is very known in the software development area. It's all started at Microsoft with Adam Shostak. He wrote by now 2 books. I think Ian mentioned one of the books in his talk just a few hours ago. That's recommended. I can just stop giving my presentation and let you read the book. No, that's not true. I think threat modeling is something that more people should do, and very important to remember, and I hope we will learn that during the presentation, is that we are not limited to software alone. We can also threat model hardware. We can threat model complex systems. We can threat model, like a car ECU is a little black box, you can still threat model that. What we're going to talk about, I'm first going to go back in history, and I know Halvar yesterday went back to the 80s. I'm going back to 67 later in the presentation. So we're going to look into history. Then we're going to see threat modeling in computer science. We're going to go through the threat modeling basics, what you can do, which tools you can use to perform threat modeling. And then we'll make some conclusions. The 4 key questions that we want to answer when we do threat modeling is what are we building? We have to know what we are building. What can go wrong? And this is where I think it's very important. Who does pen testing or anything offensive in security? Okay, keep those hands up. And who's more into defensive security? So why don't we all work more together to build more secure systems? It's awesome fun to break systems. It's even more fun to actually build secure systems. It is true. We have to know what can go wrong. That's thinking with the attacker mindset. What can we also do about what can go wrong? And how good is our analysis? Why do we do threat modeling? And I hope this works. Because we don't want Dave Kennedy coming in to do a pen test and yell this. Sharkeisha, no! That's an inside joke. Anyway, if you go back to history, and now we're talking about physical items. No, it wasn't Dave Kennedy. Anybody know what is this? When the first car came out, they needed to make it stop. Does anybody know why we have improved brakes? Exactly. Brakes are not developed further, and technology is not researched further to make cars stop better. It's made to make cars go faster. There's some prime examples of threat modeling gone wrong in history. There's the Tacoma Narrows Bridge. It was a very nice bridge at the time that it was built. It was the longest bridge in the world. But they didn't take into account the wind in the area where they built it. So when it was finished, there was a very specific situation where there was a lot of wind. It started to vibrate, and after 5 minutes, it just collapsed. Everybody knows the Hindenburg, very familiar with that. It was actually a very safe plane, or plane flying thing. Zeppelin, yeah. And it was not supposed to break, but it was a very specific set of situations. Basically, they were late on arrival. They had to do some very fast movements. A cable broke, ripped one of the bags. They actually thought about safety issues when they built it. There were several bags of hydrogen in the Zeppelin to keep it up. And then when they touched the mast, one of the cables gave static, and it basically just caught fire. Some other examples that everybody's probably familiar with, where some kind of treadmilling was done, but very specific situations were not taken into account. The Titanic and Chernobyl. So this made me think, when I was looking at these situations, how can we build systems better to make them more secure and actually think about all the things that can go wrong? Is everybody familiar with the WARE report? This is a report that was written in 1970. It was actually mandated in '67, and we're going to go through a few details of this report here. So, it was supposed to recommend hardware and software safeguards that would satisfactorily protect classified information systems in multi-access resource-sharing computer systems. What are we trying to do today? We are more than 40 years later. We are trying to protect multi-access resource-sharing computer systems. Basically, what they moved from was, and it doesn't matter what you can call it cloud, you can call it the Internet of Things, you can call it ubiquitous computing, and I always select difficult words to say so I can mispronounce them. It's basically the systems like they were used then, and the Raspberry Pis, and everything that we have now is a computer. They analyzed this, and they came up with what I found was the first documented threat model in computer history. This is actually a very awesome design. Do you know that Chris Nickerson is in here? No, seriously. So, remember his talk? He was the maintenance man? They thought about him in 1970. He wasn't even born back then, right? Me neither. So if you look at the threats that they documented in 1970, do they sound familiar to you? Is this what we're trying to prevent now? We should do more of these drawings, more analysis of computer systems that we're trying to build, but they don't need to be perfect. I think that's a very important message. We don't always have to be Batman. It's okay to look like Batman. Like, if I send my child to a carnival, he doesn't need to be Batman. He needs to feel and think that he's Batman. So this is the concept of minimum viable product. If you look at the WARE report, and I suggest everybody reads the WARE report, because those people that don't know history are bound to repeat it. We're talking about minimum viable product. So the WARE report identified all the issues in 1970. The first, one of the issues that they identified was memory corruption and shared memory as an issue. If you look at a lot of the exploits are memory related exploits. The first time that ASLR was actually implemented was in 2001. That is more than 30 years later. And the final implementation was in 2007, when all the major OSs supported ASLR. This is actually another example of minimal viable product. Everybody wants to play a game. We were out last night, and this is actually a picture from last night. I like to use pictures that are just related to nothing. We were having fun. We entered the bar, and there was this game. It's just a simple wooden log. You get a hammer, and you get nails. You don't need more to have fun. You talk about the least product that is valuable for your customer at that time. And another good example of minimal viable product is Windows XP. What we've always focused on Windows XP as the vulnerable part of our existence is basically why we as an industry exist, protecting Windows XP, right? But there's a very important message when you talk about minimum viable product. You learn through shipping. When I talk about learning through shipping, we as a security community, as security consultants, always talk about the cost of repairing vulnerabilities in the past. What we forget is that there's also a cost in not shipping a product. If you don't ship a product, you don't make money. So you have to accept that at a certain point, you're going to ship a product that's probably vulnerable, but people will want to pay for it, you're going to make money, and you're going to be able to improve it. And that's how Microsoft went from Windows XP to Windows 7, and now the shit show that's Windows 8.1. Threat modeling, the basics. And this is basically the process that I use when I work with clients and do threat modeling. There's two streams. You look at a system holistically. You basically just look at a system, identify all the components. You can use different tools that I will mention later. And you also identify the countermeasures that are in place. And when you look at a system, you don't only look at the software that you're building, you're also looking at the platform that you're building on and the security properties of the hardware that you're building it on, or that it's supposed to run on. Because there are countermeasures there that you can leverage. You shouldn't think that, for instance, you should build your own crypto. I think that's the worst idea, and we see it a lot. But there's always things that you can use in the OS and on the hardware level that you can leverage there. So identify all the countermeasures. At the same time, you're going to identify the threats when you have a proper diagram or a proper story behind your system. But what's also important is that you identify the threat actors. Because a threat is nothing on its own. You need somebody that basically hits you in the face, leverages the threat, then you define the threat model and you report. If you do this internally, there's not going to be a final report. You hopefully put this in a loop and make sure that your system is better. Again, I stress that if you make a threat model, it doesn't need to be perfect. It needs to be good and understandable, but it doesn't need to be perfect. There's nothing like perfect. First thing you can use, diagramming. Everybody familiar with data flow diagrams? Probably so. So there's what you basically try to do when you look at a system, and this is in the best case scenario. This is let's say a more complex system. You're going to start diagramming. You have your actors, which are basically the squares, your different processes, which are the circles, and then the data source, which are the two lines with text in between them. That's, for me, the best way to look at a system. But sometimes this is not enough. You're going to have very small parts of your system that you need to analyze further. And for that, what I normally use is a Swimlane diagram. So you're going to, this is basically the same diagram as I drew before, but this type of diagramming is, for me, easier to look at very specific parts that you need to delve further into. The most important thing about your diagram, when you make a diagram, is that it tells a story. If you can go through your diagram and there are no what, where, who, any questions left, you can just tell a story from your diagram and basically describe the whole user experience and what happens with your system, then you have a good enough diagram. There will be moments that you cannot use diagramming. For instance, if you use an external API, you don't know what happens inside. You know what you send to it, you know what you get back, but you don't have the code and you don't know the whole system by yourself. So in that case, what I normally do is do workshops with a team that are scenario-based. The ideal way to approach that is to think like in a movie, and we actually call that movie plotting scenarios. You think, what is the worst thing that can happen in this application? And again, I don't have any Sun Tzu quotes. I have a Voltaire quote. This is very important to remember. You can always build a better diagram, but at a certain point, you have to live with your diagram. And what I suggest there is you also record your assumptions. There's always things that you don't know about your system that you will have to just assume. Just record those, and as your diagram or as your threat model lives on, those assumptions are going to be proven true or false. And because you record them, you can track them and then take them out, basically, on what you learn further about your system. Once you have built your diagram or basically made a story about your system, the next step you're going to do is identify the threats. And again, there are several ways to do that. Microsoft, they suggest Stride. Is everybody familiar with Stride? Hands? Some people are. So Stride is basically just a mnemonic to remember the most common types of threats you see. So spoofing basically means pretend to be something or someone else in the system. And I think the slide is important because it indicates where you find those. If we go back, I'll try to go back if I can. So if you look at this diagram, and I'm very sorry that I don't have a whiteboard or anything. So between, for instance, the web browsers and your processes, there are boundaries. Those boundaries are very, very important to remember because they are mostly the places where your threats will exist. If we go back to the Stride slide. So this indicates spoofing, pretending to be somebody or something else in the system. Those are usually found in external entities, the squares you saw, users or processes, and processes were the circles you saw. Tampering, which is basically changing information in the system, that's usually found in data stores, data flows. Those are the lines between the different between the different processes and the actors and the data stores, or in processes. Repudiation, and I always forget what that means. No, I'm not kidding. Repudiation is basically being able within your system to say who did what, when, why. If you can subvert that, you can break a system. So those are usually found in processes. And threats regarding to information disclosure is, well, everybody understands information disclosure. Those are usually found in processes, data stores, and data flows. Talking about denial of service, those are found in processes, data stores, and data flows. And then elevation of privileges, which is the golden source, are usually found in processes themselves. So this is the point where I have to mention the card game that is called Elevation of Privileges. It is a free card game that is developed by a Microsoft team. You can download it, you can cut the cards yourself, and basically with your whole team, you can play the game, you make the diagram of your application, and you start identifying threats by playing the card game. It's a bit like poker. There are trump cards. It's actually very fun to do, and you should try to do that with your different systems. Obviously, Stride is not always enough. It's a very good tool, but it's also limited because it has only the 5 threats that they list there. So there's another way to identify threats, and that's based on attack libraries. Everybody's familiar with the OWASP Top 10. That's basically an attack library you can use. But you can also make internal checklists. As you threat model, you build a body of knowledge that you document and that you can go to. You'll be able to threat model applications that are similar to previous applications or systems that you have built. But there are also threat models out there from other systems that are similar to your systems that you can leverage. Then the KPEG, I've tried to work with the KPEG. It's a very complex system. It's very deep. There's a lot of information there. but it's hard to relate that to a treadmilling exercise. I'm much more in favor in using Stride and building your own attack libraries, because a lot of the applications and systems that you will build or that you will maintain are very similar. So using your own attack libraries, I think, is the best way to do it. They are very useful if your developer team is not very familiar with attacker strategies. So if you don't have a lot of people that have the attacker mindset, then it's very, very interesting to use attack libraries. Another tool that you can use, and you see that I don't offer one way to do treadmilling. I think treadmilling is about knowing the tools that you can use and apply them in the different situations. Bruce Schneier had a nice thing to say about attack trees, and I find them very useful when you do treadmilling for black box systems. Like if you talk about a car ECU or a payment terminal, you don't know a lot about those systems, and analyzing them up to the silicon is very expensive. So what you're basically going to do is see where are the assets in that thing. If you talk about a payment terminal, for instance, there's going to be keys in there, there's going to be firmware that you can obtain, and you identify those as goals in your attack tree. Those assets become what the attacker wants out of your system. That's valuable to the attacker. And then you're going to do step-by-step an analysis of what does an attacker need to do to obtain those assets. Because when they have those assets, your system is compromised. I've tried to draw some kind of attack trees. You see that, for instance, if you do step 3.1, you don't only facilitate attack 3, but you can also facilitate attack 2. What I really like about attack trees is if you build them this way, you identify the places in your system that you can protect your application or your system in the most economic manner. Now, what can you do? The different approaches in threat modeling. There's an asset-centric approach, and that is the easiest way to do it for teams that are not very familiar with the attacker mindset. So you're going to identify the most critical assets, what is valuable to you. But an asset is not only what is valuable to you. You want to protect what's valuable to you, but you also want to protect what's valuable for the attacker. What does he want to have out of your system? So you're going to identify the assets, and from there, you're going to build your threat model. The other approach is, again, the attacker mindset. An attacker-centric approach, you focus on your threats and your threat actors and build your threat model through there. The fourth step, and I believe this is the most important part, for me, it doesn't end when I generate a report, and you will be very disappointed when you see a threat modeling report. Everybody expects like a fancy diagram with all like bombs exploding and shit like that. Doesn't happen. It's basically you create an Excel sheet where you list all your different threats, what their impact is, and how you're going to remediate them. So you identify the threats, you document them, and Excel is the best tool ever. I think like 90% of the companies in the world still run on Excel. You validate the threats, and with validating the threats, you see if they are feasible, and if there are threat actors within your threat model that are actually, how should I say it, credible to use those threats to compromise your systems. And then you have three choices. You can eliminate the threat, you take it away by re-engineering your application or system, by building in safeguards. You can mitigate a threat, and with mitigation, you don't take it completely away, but you make it more costly for your attacker to actually use the threat. And then, and that's very, what's the English word? It doesn't come natural to security professionals to say, we accept the threat. But at a certain point, and we go back to the concept of minimal viable product, there is a need to accept the threat. Sometimes it's too costly to remediate it, and sometimes your users are not asking for it. So why would you want to spend money on mitigating them or even eliminating them. So apparently I've gone way too fast. Conclusions. Treadmilling is not rocket science. I'm not the smartest guy in the room. If I am, then I'm probably in the wrong room. So I believe everybody can do it, but it's really focused on experience. It's what you know about your systems, about your organization, and that's why I don't like to do the treadmilling on my own. If I do it with clients, I like to work with the teams themselves, because they know what's valuable to their company, and they know their systems better than I do, or than I will ever do. Models need to be good, reliable, but they don't need to be perfect, like I said before. And it's important to know that it's a cross-disciplinary function. So talking about experience, the best way to do it is work with your developers, but also work with your security people, your QA people. I love QA people. Does everybody agree? Okay, one. So QA people know what goes wrong in your system. They see that all the time. Developers build functionality. QA people beat the shit out of functionality and see what goes wrong. So they become very valuable in the treadmilling process. So what you will notice, and when I do treadmilling training, I don't have like set exercises that I do with a client. I work with their own systems. We basically create different groups, and people start modeling on the whiteboards and on the flip charts. And you see that they are familiar with the concepts. You go through the theory, but you see that they are familiar with doing this. They already have a way to diagram, and it's normally everybody in the company diagrams in the same way. It's just about structuring the treadmilling. Everybody talks about lean and agile because we don't need to document anymore, and it's much faster to create vulnerable applications. But treadmilling is about requirements, just as an agile process is. But it's about security requirements. It's about building better quality products, and it's about building resilient products. What you need to do as an organization is build treadmilling explicitly into your engineering culture, both through training, but also through process. You make the process that is also already implicitly there explicit, and make it mandatory. If you look at Microsoft, for instance, if there is functionality that somebody wants to build into a product, they need to come with a treadmill before it's even considered to be implemented. And I think a lot of organizations that build software or that build systems should implement a process like that makes treadmilling mandatory. So you start thinking as an attacker, and you start building defenses from the start, and not have a penetration testing come in and give you a report with 200 cross-site scripting and SQL injection vulnerabilities. Let's see. There was something else I wanted to say. Right. What's also important to know is that treadmilling is not something that you only do when building new systems. There was a very good presentation, I think, 1 or 2 years ago at 44Con by Ollie Whitehouse. And I forgot which, I think I'm not going to mention which company he's with because I don't remember. But he provided a methodology to treadmilling existing systems. That's something you can also do, because treadmilling is about creating the diagrams, creating the story behind your system. If you look at an existing system, you can build it from the ground up. You look at your standard setup of your operating system. Then you install the prerequisites for the system you are building, and you see what changes in the system. Are there extra users created? Those are trust boundaries. If processes run under different users, there is trust issues. You're going to see which components are installed, and you're going to build your system further and further, and you're actually treadmilling an existing system. So it's not limited to only building new systems. It's also applicable to existing systems. And in that sense, defense teams can start threat modeling their whole organizations, system by system, to build better defenses. And I think I've said everything that I wanted to say about threat modeling. Are there any questions?
Do you have any examples that you could show us of what some of these things look like? Do you have any examples that you could show us of what an actual threat modeling exercise looks like?
So normally, does anybody have a flip chart? Normally I do this in the presentation itself, but I haven't prepared it here.
Ah, okay.
Okay, no further questions? Then thank you, Wim, for the presentation.
Thank you.